Top, we've got Pablo, and you're doing
Yes.
spatial hashing in fourth.
Here. See the screen?
Yeah.
Well, I'm slowly developing a physics engine for the language, and a key part of the physics engine is the search of the neighborhood of an object. I show an example. I don't know is see the animation or I have high latency, but this is a basic physics engine with colliding balls. And the question here is you need to detect every collision in this object and search for the collision. You need traverse the square of the quantity of this object, and then slow very fast this program, and then I need a structure for speed up this situation. Well, I searched in the web. I found this guy, Matthias Müller. We have a very good information about this subject. I use the documentation he write about spatial hashing. Here is the PDF, and show the problem. The problem is get the particles, the collision between particles, and say, well, the naive solution is very costly. And then he say one of the basic structure for accelerate this question is make a grid and check only the neighborhood of the grid of an object, and then you need a store in the grid. And the first solution for storing a grid is make an array for grid and make a linked list of the object in every cell of the grid. And then this is not safe for this guy, but he tried to avoid this representation because I think it's reasonable. If you have a linked list, you need the double of memory for storing any array. Because you need storing the number and the pointer to the next. And then make a dense grid representation using a trick of storing the index of the list of particles and use the current cell and the next for search for obtain this object. Of course, if of course is use a hash. You don't need represent the entire grid. only a fraction, then you have collision and need resolve the collision for a hashing array. Well, then he explained how make this structure, how calculate this number, and implement in an example in JavaScript. And the two core functions are create the array, the hash array, with trees with these 3, 4. These 3, 4 are the description of the algorithm saying here. Count the quantity of objects in every cell, do the partial sum, and fill with the number he needs. And then, well, I say, I implement it in fork for see how work and make the same algorithm with for, and it's very similar. Here is the 3 loop for, where are the same. Is different in the reference of memory because of for, but it's the same. You can see this for is this, the initialization of the number of the object, and then the add the number in every cell of the hash, and the calculus of the number of the object. This is build the hash, and this is the JavaScript version. And the other function, important function, is carry for a neighborhood. This is the JavaScript version, and this is the fourth version. I do a simple program, write particles in the screen, and check the neighborhood of the mouse position, and draw the balls in near the mouse. Then this is the example when where I have the mouse. You see the rectangle, the white rectangles. Is the execution of the work for querying the neighborhood. This is the same implementation of Matthias Müller, this guy. And then, like a for programmer, always ask, can be more simple, and then thinking about the document of Matthias Müller, I think, well, perhaps I can use the original and no need count the max the quantity object and do this tricky for obtain the correct object, because first the number of objects is always the consecutive numbers, and perhaps the position of the number, call it, o sea, I don't need a pointer to the next because the position is the number of objects. I have well, this is the first part. And then I try to make this representation, and this idea come to me. Well, this is the idea. I have the two array, the grid, the representation of grid, and an array of a number of objects. And when I insert an object one, the space in the is a mark for a no object. Can be -1 or 0 or depend of my implementation. I use in my implementation -1, but in this graphic, no. Then I insert a 1, and the algorithm is copy first the previous value of the grid in the object one, and fill the grid with the number of the object in this space. When add the object do the same. The object do here is separate, and then store in the grid in the correct place, and the third object do the same. When I have a collision, I store in the correspondent cell the number, but first copy the previous number of objects in the array of the number of the object. Then I can reconstruct the list. These two objects are the object 4 and the object 2. And the object 2 have a end of list, and then only the list 2, 4 are the object in this place. Object 5 do the same. In 5, store the one, the previous one here. Then the list are 5, 1 in one end of list. Then I have the two objects. And third object, for example, 6, in the same place of 4, copy the 4 in the place of 6, put the 6 here, and for reconstruct the list, I do 6, 4, in 4 is 2, yeah, and in 2 is end on list. And no need pointer. The pointer and the number of objects are similar. Then this is the implementation of this idea. Now build the array is converted from this, the tree loop looping with the object in one loop. And the loop only copy the two numbers in this explanation. Only make copy this number here and copy this number here. Artists take the number of the matrix and store in the mat list, and copy in the matrix the number of the object. And the carry is the same. I show. Then this build the matrix is converted to this, only to this. And because you no need you no need know the quantity of object, because you make a loop, one loop only, and you need acá make 3 loops with the number of objects. You need n draw or know how many objects used in this representation, and here not, and I can do in the same time with drawing the object. For example, in this case, here is when you update the position with the velocity, and I can remove this function and make the construction of the structure in this place. But for the example, I make the same structure for compare. Then I translate this in very simple version. I not take the time, but I like to see is more simple, and then I prefer this representation. And the query is a more simple too, because this is the traverse of the change of the chain of number of objects, and here I need to take the interval and count the quantity of objects, and then it's a little more simple. Well, then this is the original version, and this is the new version with a more simple algorithm. I don't know if you see the rectangle. I can fill the rectangle, change the code here, library SDL, fill. ¿Cuál modifique? Este. Here. Well, it's only this. Thanks. Any question?
So what you're doing is using the index to the number index to fetch the next item as if it were a linked list, but you don't use.
Yes.
Second. That's pretty cool. It's almost like a sorting algorithm, right? So like the was it? I think it was the bucket sort, but it's not. I don't really know much about sorting, but that's pretty cool, that idea. So aside from that, the graphics didn't look too fast, or I don't know if it's my internet, but is it faster than the original implementation, or is it about the same but less code?
I don't see if the algorithm is fast. Because I don't see. I need to make a demo with much more option. But in the first demonstration with no acceleration structure, if you add too many objects, you see in the computer how the calculus is start to slow.
Yeah, in the one with the lots of balls, right?
How?
The one with the that had the entire screen covered, right?
I don't understand, Julian. Sorry.
Because this demo, the one you're showing right now is the one with where the walls are falling and colliding, right? And the previous
Yes,
one that had the filled rectangle is the one that makes the
yes.
program go really hard.
In this now is a slow down. It's a slow down, and is I collapse because not have space. But you note the slowdown, and theoretically the with the new structure I can handle more object and not slow down in the calculus of collision.
Oh, that's pretty cool. I really like the idea of doing away with the linked list.
Yes, I don't know why not use this simplification. Really, I don't know. I only search for a basic structure for optimization, and then I found this organization for make a more simple version. I don't know
Oh,
if it's novel, is original, or I simple coding and see he work.
oh, okay. No, I think it's used in sorting, but I
No,
think it's
no,
pretty good.
I
No, it's not.
don't no need sort in this structure. It's caching.
Yeah. Oh, okay.
Do you also have plans for a 3D situation?
Again, sorry.
Do you also have a plan to make it working in a 3D environment?
If I understand well, is two dimension. I plan
No,
to.
three. Can you? Do you have a plan to transform it into 3 dimensions?
Yes, yes.
Okay.
Sure, this year I making a 3D environment, and I need this this structure for make the collision, because it's too slow if you not have this class of structure.
Pablo, I take it when a ball moves between cells, I didn't quite get. I take it you have to delete the entry and insert it into the next grid position. If it as a ball moves.
I try to understand.
Yeah.
You ask about how reconstruct the structure when the particles move.
Yeah.
Every frame, I build the structure again.
Yeah.
But
Okay.
it's not very costly.
Okay.
It's linear.
Okay.
If I compare, it's quadratical.
Yeah.
And this structure is linear.
Yeah. So it's not even worth trying to modify the list. You just rebuild the list.
Exactly.
Okay.
Rebuild all.
Okay.
And the new version, the simple version, have more room for optimization, because it's in one no have three, no, you don't have three loop, you have one, and you can put this loop in the drawing of the object, for example, and this disappear the loop disappear because está is in the drawing the wall, calc and fill the structure.
Yeah. Do you think it could be parallelized? If you have, 4 or 8 processors, can you build individual grid areas independently?
You for parallelize, you asking, you need a coherence in the reference. I don't know how make the reference. You need no lost the reference of every object, but every object is a position in the array. The key part of this algorithm is I use the position of the array like a number of the same object, and then I don't need the pointer.
Any other questions? Okay. So thank you, Pablo. That was excellent. Brilliant.
Thank you.
That was
to you.
great.
Thank you.
Thanks.
I